But we're going to talk and focus today about solving, and I'll just call it day 2 actually, solving for unknowns. And like I said, we've already kind of done something like this when we talked about continuity, and that first step is the same step as the previous topic that we've done when we were doing for the unknown for continuity. It was, you I even put one of them as the option or onto the on the optional on the as one of the options on the take-home quiz. And basic premise is that, of course, we have f of x, which is equal to g of x and h of x, typically for x less than or equal to a and x greater than a. And it'll be stated that f of x is differentiable and need to find non-x values that make this statement true. And remember, differentiability implies continuity.
Miss, could you slide up a little bit, please? Thank you.
So, really haven't written anything different than what we did yesterday. Differentiability algebraically. It's the second day. But today we're going to be solving for unknowns. So, in yesterday's questions, the idea here was that you were investigating differentiability. You were checking to see if, in fact, if this function f is continuous, this piecewise function of f was continuous at x equals a. So you needed to check to make sure the left-hand limit was equal to the right-hand limit and confirm, of course, which is obvious at that point if that part is true, equal to f of a. In today's problems, I'm telling you that the function is differentiable. So it is differentiable, or the question sometimes will say find a value that makes it differentiable. So the idea, instead of the equal left-hand limit and right-hand limit, and instead of questioning it if it's equal, they are equal. As such, we are able to create equations. Now, g of x and h of x are going to have unknown values inside there. They'll have values of a, b, use typically two letters. And as a result, they're going to require system of equations. So this topic requires system of equations. SOE. All right. So we're gonna have to set up problems like that. So let's do an example. The best thing here is just do an example. And most of what we're gonna be doing is just an example. So in terms of the steps, step 1 is we're going to set up equation for f of x continuous. Step 2, set up equation for f prime of x continuous. Step 3, solve the system of equations. So there's a 3-part process to this assignment. Okay. We're going to set up for f of x equals, now it's going to start as a limit question in terms of the setup. Okay. The setup will have limits in there. But we're going to evaluate those limits. In other words, when we see an x, we're going to replace it with the number, just like we always evaluate limits at a point. And that's going to give us an equation. Now, there's a lot of places you can go really wrong here. If you have not been practicing, if you have not done the previous topics, if you're not making sure to do it right. And here's what I'm going to tell you about it. You can't take this as, I just can't do this topic. I'm struggling on this topic. Oh, well, I'll move on to the next. Again, it doesn't work like that for calculus. I can't stress it enough. Calculus does not work with the mentality that I don't get this topic, I'm going to move on. Because it requires it later on. We're going to be doing many problems that we're going to require many of the same features or steps or conceptual understanding. So do take the time in making sure you got that. Let's do an example. Wrong color. Go back. And I'm making this problem off the top of my head. And it might have, most likely my answer is going to have fractions, which I think are good. We don't want clean answers because clean answers, don't always happen. So f of x, and typically these problems are going to, now, I'm going to introduce to you other types of derivatives. As we go on through the rest of this week and into next week, we're going to learn how to take new types of derivatives. Now today, you only need to use the power rule. But remember, x is the variable. So a lot of students do get confused and they try to do it with the other letters when you take the derivatives, but it works the same. Remember, the values a, b, and c, or whatever I use are constant. X is the variable. So we'll do something with like ax squared minus b for x less than or equal to 2. Actually, we'll go with bx. And we'll go with um, 2b plus a, 2bx plus a for x greater than 2. Should work. Should work. Find the values of a and b that make f of x continuous at x equals 2. And I put at x equals 2, but in reality, it's just continuous because two piecewise functions for f are both polynomials, which are continuous everywhere. And we have that. And so we're just checking at 2. Okay. All right, so first step, continuity. So f of x, continuity. Which means that the limit as x approaches 2 from the left-hand side of f of x must equal the limit as x approaches 2 from the right-hand side of f of x. Now, this part right here is a technical piece, but it is an important piece to show because it demonstrates your understanding of what you are truly checking. Some people go, well, aren't I just plugging in 2 into the top and setting it equal to plugging in 2 into the bottom? And in the end, and mathematically, that's all you're doing. But we need to understand why we're doing it because of this definition of continuity. Now, you may want to be able to do that in one step and do it as one side of the equal sign, or I like to just do it and break it up as 2. So the limit as x approaches 2 from the left-hand side of f of x is the same thing as the limit as x approaches 2 of ax squared minus bx, because that's the left-hand one. And what that, all of that means, like I just said, that means I'm going to plug 2 into that top equation, because that's how I evaluate the left-hand limit. What do I get when I plug in 2, when I evaluate this limit as x approaches 2? What do I get?
bring x2 plus.
No.
Oh, it's another 2bx plus a.
No.
That's really.
How do I evaluate this limit? How do I evaluate this limit? Now remember, when you evaluate a limit, you no longer have any x's. You're evaluating the limit. Now there's going to be a and b in your answer. Plug in 2 for x. Perfect. How do I plug in 2 for x? What do I get? That is correct. Plug in 2 for x. What do I get? I get a times 2 squared minus b times 2, which is 4a minus 2b. And I'm going to circle that. Okay. I plugged in 2 for x. Now I'm going to do the limit as x approaches 2 from the right-hand side of f of x, which is the limit as x approaches 2. Now, some people will kind of skip this, some people will just go directly to having this and going to, well, actually, let me make that yellow so it's a little bit more see-through. Some people will go directly to here for my first equation in terms of the work, and same thing on this other side. So this one is 2bx plus a, which gives me what? Which gives me
It's 2b 2b2
2b times 2.
2 times 2 plus a.
Good, which is 4b
Plus 4b
plus
plus
a plus a plus a plus a. Okay. 4b plus a. We don't combine them. That's 4b plus a is 4b plus a. So this gives me my first equation. 4a minus 2b equals 4b plus a. And I think I might have to adjust my equation a little bit. Yeah, I have to adjust my equation a little bit. In my equation up top, can you just add a plus 1? Just please add that plus 1 right there. It's going to be needed. Plus 1. Please add that. So when I do it, I'm just going to add up. I'm going to have an extra plus 1 here, a plus 1, a plus 1. And so I get this right there, plus 1. I just added a plus 1 to the problem for the right-hand limit piece. It's the reason why I need that is because or else we're not going to be able to solve the system of equations. The answer is going to be 0. That's what happens when you try to do a problem in your head. At least I recognize where it was going to go wrong. It won't happen on your actual problems. All right. That's my first equation. Now, if you want to, we can clean this equation up right now. So, I typically like to leave it like this for right now, and then we'll come back to it afterwards in terms of cleaning it up. So that's my first equation. That's my first equation. There are 2 unknowns, though. There are 2 unknowns. So because there are 2 unknowns, I can't solve for a and b yet. I need a second equation. So as such, I'm going to go with the problem, and I'm going to have to find out f prime of x. And all that means is I take f of x and I take the derivative of it. Now, it is a little bit different when you take the derivative with constants. It might feel like it is, but it really is not. That numbers a and b are like 5 and 4. It doesn't really matter what, we don't know what they are yet. They are constant. So what do I get for the top derivative? The ax squared minus bx. What is the derivative of ax squared minus bx? Remember, it's just the power rule.
AX minus B.
Close. Close.
2AX minus B.
2ax minus b. Don't forget that that 2 has to go to the bottom for the power rule. What do I get for my right-hand limit derivative? The 2bx plus a plus 1. What is the derivative of that?
Would it be like 2B plus A
Close.
or just 2B?
Just 2b. A is a constant, so its derivative is 0. 1 is a constant, so its derivative is 0. 2bx is linear, and so the derivative is just the slope, which is 2b. Or you can think of it as 2b times x to the 1, so the 1 times 2b, which is 2b, times x to the 0, which means that x and 0 is just 1. And we do the same thing here. We're going to do the limit as x approaches 2 from the left-hand side of f prime of x, which is, and I'm going to actually just go directly into it this time around. That's going to be 2a times 2 minus b, which is 4a minus b. And then I'm going to take the limit as x approaches 2 from the right-hand side of f prime of x. Oh, there's not, and this one's nice because there's no x's, so it just gives me 2b. Now, I didn't show the extra additional steps like I did here in rewriting the function, because I believe that we should be comfortable now if we followed the previous step, what's happening there. And this gives me my next second equation, 4a minus b equals 2b. So there's my step 1. I found my equation through continuity of f of x. Step 2, I found my equation through f prime of x continuity. And now it's just an algebra problem. Now it is an algebra problem. Time for algebra. Time for a system of equation. There is no more calculus involved in this problem. There is no more calculus involved in the problem. I have two equations. I have 4a minus 2b equals 4b plus a plus 1. And I have 4a minus b equals 2b. And I have to find a and b. So I've used the calculus. The calculus, and this is what happens a lot in our course, the calculus in the end just becomes an algebra problem. So all that work that we've done on the left-hand limit and right-hand limits, plugging it in to evaluate those limits, led us to the heart of the problem. Find a and b right here. So now it's a Math 2 problem. Now it's an advanced algebra problem, all right? So when you're doing this work, ask yourself, and you got to realize, are you having problem getting to these equations? That's a calculus. And then, are you having problems solving this? That's algebra, okay? So in the end, when you're creating these equations, like I said, in the reality, all you're doing is plugging 2 into x and setting it equal to plugging 2 for x on the bottom. That's your first equation. Then you find a derivative, and you do the same thing. You plug in 2 for x, and you set it equal to plugging into, oh, there is no x, for the bottom, and that gives you your second equation. If you just try to memorize it only like that, though, you're not going to have a conceptual understanding of continuity and differentiability with limits, which can hurt you in the long run. But that's what we're doing, and we got here. Now, it's algebra. In reality, I always say algebra is algebra. Good algebra is good algebra. Your teachers, when you learned your algebra, your advanced algebra, your system of equations, taught you probably in certain methods of how to identify, how to work through the problem. I'm not here to tell you you're wrong in how you solve the algebra problem. I'm going to walk you through the steps in how I would do it. And why I would do it, because remember, there's two methods of solving this system of equations. Substitution, where you solve for A or you solve for B and plug it into the other, or there's the method of elimination. Most likely elimination is going to be used. So I'm going to clean these up. So the top one, I'm going to look at this 4A minus 2B equals 4B plus A plus 1. That's going to give me something really ugly. The question is, if you can solve for A or if you can solve for B, then I recommend you using substitution. If you can solve it cleanly without fractions. So this one over here on the right hand side would give me 4A equals, oh, that's a 2B, sorry, 2B equals 3B, because I add B to both sides. Can I solve for A or B cleanly on this right hand equation, or the second equation? Yes or no? Can I solve it for cleanly with no fractions?
No.
No. So I would recommend that you probably don't go about doing this substitution, but you can, okay? And it's actually not too bad. If you wanted to, you can get A equals 3/4 B, and that works, and therefore you can use substitution. This is just one way. There's like 5 different ways you can go about solving this problem. Since substitute, this is how you would do substitution. So I'm going to first show you how to use substitution. Okay, and then the other one, I'm going to get, what do I get? I might get minus A minus A. I get 3A minus 2B equals 4B plus 1. I get 3 plus 2B plus 2B. I get 3A equals 6B plus 1. Okay. And I'm going to take the value of A and I'm going to plug it in. I got A equals 3/4 B. Okay. Now, the method of substitution takes like a leap of faith at some point in terms of I solve for A or I solve for B. It doesn't matter which one you solve for first, and then plugging in. I'm going to show you the elimination method. The elimination method is pretty much always the same. If you're very good at just algorithms, I think elimination method is a little bit better for just trying to run an algorithm in terms of like I do this, then I do this, then I do this. Doing this gives me 3 times 3/4 B equals 6B plus 1. This is the substitution method. That gives me 9/4 B, this is algebra, equals 6B plus 1. I hate fractions. So what do? This is just my recommendations. When I get to a problem like this, at this point, what I do is I just multiply everything by 4. The common denominator. All right? I like doing this because it makes me feel, it gets rid of the fractions. I don't want to have to subtract fractions and so forth. All right? I multiply by 4 on both sides. I balance the equation. So that gives me 9B equals 24B plus 4. Okay? I'll subtract 24B from both sides. That is, what is that? 15, negative 15B equals 4. Divide by negative 15. Gives me B equals negative 4/15. And actually, that's more of a block answer because that is one of the answers I'm looking for. Oh, it's ugly. Oh, it's a fraction. It's okay. And you want to practice your fractions right now. Your homework doesn't have everything like ugly like this part. Okay. Now that I found B, what do I do? If it felt overwhelming with you in terms of how I solved it, there are other processes, and it takes practice of how to solve a system of equations and how to go about doing it. They're not always the prettiest in how they're written, and you'd have to work with the way it is. I'm going to show you how to do the same problem, one other method, and we're using the elimination method. But how do I solve my next step? I found B, now I got to find A. How do I solve? How do I find it? I zoomed out for a reason. I found B, now I got to find A. I zoomed out for a reason.
We're just plugging in after doing the equation.
There you go. So I had A equals 3/4 B, so I'm just going to plug in B for that part where I solved for A. So A equals 3/4 times -4/15. Those 4's cancel each other out. And 15 divided by 3 is 5, so I get -1/5. If you wanted to write it as -12/60, I'll leave, and you want to leave it like that, perfectly fine. You don't have to simplify fractions in my class. Of course, when you would do a multiple choice question, you would see -1/5. So that's how I solved the system of equation using the substitution method. Now, I could have solved for B. I could have solved for B and I got B equals 4/3 A and then plugged it in over on the other side. I could have done that. I could have solved for A or B on this one, which would have been really ugly, and then have plugged it into the 4A equals 3B. You can do it as any way you want to with the system, with that method. It's algebra. Same problem using elimination method. Okay, so I had 4A minus 2B equals 4B plus A plus 1, 4A minus B equals 2B. All right, so here's what I have. Now, if you want it, now, like I said, this is more algorithmic. And you might feel more comfortable doing this method because it's pretty much do the same thing. We move all the A's and B's to one side and we leave all the constants on the other side. And typically you want to go A, B equals constant. So what that means is that I'm going to move these to the left-hand side and I'm going to subtract this. So when I get the first equation, the top equation becomes 3A, because 4A minus A is 3A, minus 6B, because -2B minus 2B minus 4B gives me minus 6B, equals 1. That's my top equation written in a system of equation, our elimination method form, standard form. We write them in standard form is what I'm really saying. And the other one becomes 4A minus 3B equals 0. I subtracted 2B. Which variable am I going to try to eliminate, A or B, on this problem? Which is the easiest one to eliminate, A or B?
A.
It's no, it's definitely not A, it's B.
And
It's
this
definitely B. Why is B? What?
I don't know.
Well, why did you choose A?
Can't you multiply by -2 so it'll cancel out with the -6?
Exactly, because the coefficient for B and the bottom one is a factor of the coefficient on top. In other words, -3 goes into -6. You can do it with the A, but then you have to multiply the top by like -4, and then you have to multiply the bottom by +3 so that they're opposite signs and the same. Oh my, you don't want to do that. So what I'm going to do here in elimination, this is just elimination. This is just algebra. This is not me as your calculus teacher. This should be your algebra teacher here in your head. I'm going to multiply this by -2b. And the reason why I want to multiply this by -2b because I want this I'm going to focus on the -3a or 3b, sorry, and I want it to be the opposite sign. So now I get 3a minus 6b equals 1 over -8a plus 6b equals 0. Now remember, I'm multiplying, I said, oops, sorry, I meant to say -2, not -2b. I'm multiplying all three parts by -2. So 0 times -2 gave me 0. So don't forget, most people make that mistake on that one. They forget to multiply the right-hand side, but since it's 0, we still get 0. Elimination method, now that they have two that are opposite signs, we just add them down. That gives me -5a equals 1. Divide by -5, divide by -5. I get a equals -1/5, which I had already found. And then I choose any of the equations and I plug in. So I'm going to plug into the one that's the easiest one, which is the 4a minus 3b equals 0. I can choose any version of them. I can choose that one. I could have chosen the 3a minus 6b equals 1 as well. So I get 4 times -1/5 minus 3b equals 0. That gives me -4/5 minus 3b equals 0. That gives me -3b equals +4/5. Multiply by -1/3 on both sides. Same thing as fractions, dividing, but I hate dividing but I like multiplying. And we get b equals -4 over 25. Oh, that's a 3. See, I can't even read my own handwriting. 15. Two ways to solve the same system of equation. Both of them are correct. Algebra is algebra. If you were felt very overwhelmed from how to solve this system of equation, that's not calculus, okay? That's algebra, and you've done it in the past. You've been successful in it in the past. You are able to solve this type of problem. It just might not seem like that's been your focus of what you've been doing. How to solve this problem is a system of equation advanced algebra topic. It just takes practice. If you want to, some people just always like to use substitution method. Okay, you're going to be successful. Some people always like to use the elimination method. Okay, you're going to be successful. Some students, depending on how the problem is written, will choose the elimination over the substitution or vice versa, depending on the problem. Now, that's going to probably be the most efficient and quickest way so that you make the least amount of mistakes. And that's really going to only come from mastery and really, really practicing. But it's not a requirement, all right? It's not a requirement to choose solve by substitution or solve by elimination, no. Now, I'm hopeful that you can look at a problem and say, you know what? While I always like to use substitution, it's not going to be really pretty on this problem. All right, it's not going to be really pretty because I can't really solve for A in terms of B. Now this problem was okay to do substitution because I get A in terms of B and there's no constants. Okay, there's no like +5 in there. So it's doable. However, if there was like another constant in here, like if it was 2B plus 3, and then you do this and you get 3/4 B plus 3/4, and there's fractions all over the place, it can get really problematic to use substitution in that way. However, like I said, if you are able to solve for A or you're able to solve for B, then you should do it. You should use the substitution method. Some problems are really nice, and you're going to see this in your homework tonight. Some problems, when you do the second equation, you know, on our second equation, we got 4A minus 2B. This is what we got as our second equation. Sometimes you're going to get, there's not going to be two variables in that second equation. You're going to get something like 4 minus B equals 2B. There's not going to even be an A, or there might not be a B. In other words, you can solve for B without using, you can just solve for what B is or solve for what A is. And that's nice because then once you just solve for that value A or B, and then you just plug it into the other one. It happens a lot more frequently than not. Okay. But that's weird. Same concept as yesterday. The hardest part, set up your equations, set up your left, set up your right, plug in for X to evaluate the limit, and then it's just algebra. And then it's just algebra. Your homework is a homework handout. It is attached in the Google Classroom. It's going to start off with problems like yesterday, where you're going to investigate differentiability, determine if the function is continuous and differentiable, continuous and not differentiable, or if it is differentiable. And then you'll get problems, like 3 problems where you're doing problems just like what we did right now. Make sure you got those done. Make sure you have those ready and you got a good understanding of those. These type of problems will creep back in ever so often as we learn new derivative rules. That's what I have for you for today.